This is a question from February-March 2016, question 1a. The table below gives information about particles. Complete the table. The first line has been done for you. Now this table shows you 4 different particles with their number of protons, electron, the electron configuration and the charge on particle. Now if you look at particle A, you would see that it has 12 number of protons but only 10 electrons, which means this atom has an electronic configuration of 2.8.2. However, after donating 2 electrons, it has an electronic configuration of 2.8, and that is how you obtain 2 plus over here. Now for question B, now for particle B, if you can see, it has a number of electrons of 2.8.8, and it says that it has received an electron in order to achieve stability, which means that previously this atom had an electron configuration of 2.8.7, which means that it has 17 protons. Now for particle C, previously it had 18 protons and it has 0 charge. That means this particle is stable. The number of electron is same as the number of proton. For particle D, the proton number is 8 and the electron number is 10. Now electronic configuration is based on your electron number. Therefore your electronic configuration will be 2.8. And the charge on the particle depends on the differences between the proton and electron numbers. 8 protons means previously it had an electronic configuration of 2.6 and it became 2.8. This means that it has received 2 electrons in order to become stable. So your answer for the charge on particles would be plus 2. Now question B is asking you to define the term element. So the definition of element can be obtained from the notes that I have uploaded. Over here it has already been mentioned that element is a substance made of only one type of atom, and it cannot be broken down into anything simpler. So please memorize this definition. Question C. The following are gallium atoms. As you can see, we have 2 gallium atoms here with the same proton number but different nucleon number. Now, a substance which has the same proton number with different nucleon number are called isotopes. They're asking you to complete the following table. The number of protons can be determined by the bottom number that you see over here. This means that both these gallium isotopes have the similar proton number, which is 31, and number of neutron is, now we know that nucleon number means neutrons plus proton. So over here we have the nucleon number of 69. What we have to do is that 69 equals to an unknown neutron number that we are trying to find, add with the proton number, which is 31. This will give us a value of 38 neutrons, and the same method applies for the second isotope, whereby 71 minus 31 and you will get 40 neutrons. Now the number of electrons are similar with the number of protons, so the first isotope would have similar 31 and same goes to the second isotope. Now this is a question from May June 2016, question 2. They're asking you to define the atomic number and the nucleon number. Again, the definition of atomic number and nucleon number can be obtained from the notes that I have uploaded, so please memorize the definition accordingly. Atomic number can be defined as the number of protons in one atom of an element, and nucleon number is similar with the previous question that we did, whereby protons and neutrons will be added up together. Now question B. The table shows the number of protons, neutrons, and electrons in some atoms or ions. Complete the table. The first line is given as an example. So they have given you 4 different particles here. First particle shows us that the proton number is equal to the electron number. This means that this is an atom. Whereas an ion means the proton number and your electron number are not the same, because they have either donated their electron or they have either received an electron in order to achieve a complete outer electron number shells. Now let's look at particle B. Particle B also have an equal number of protons and electrons. This means that it is an atom as well. Particle C shows that it is an ion over here, an ion which has received 2 electrons. That means it has 10 electrons. And particle D does not have a similar number of protons or electrons. It means that this is an ion as well. An ion which has reduced the number of electrons by 1, that means it has donated 1 electron. Now let's complete particle B first. Particle B has 12 number of protons, so you have to refer to the periodic table in order to determine which particle is this exactly. Now a particle with a 12 number of protons means they are placed at the 12th position on our periodic table, and this is magnesium. Therefore, you should write the symbol of magnesium over here with number 12 at the bottom to show the proton number. However, we also need to write our nucleon number, and nucleon number is the sum of proton plus neutron, which will give us 24. Now let's solve particle C. Particle C has already completed the symbol and formula for us, and all we have to do is find the neutron number. Now the neutron number here would be the difference between our nucleon number, which is 16, minus with our proton number, which is 8, so we would be getting a neutron number of 8. And the final one is D. Particle D has 11 proton numbers, so let's refer to the periodic table again. A particle which has 11 proton number would be sodium. So I'm going to write the symbol of sodium over here, and we have to determine the number of proton. It is given, so I will write 11 over here, and the nucleon number is 11 plus your neutron number, which is 24 if added up. So this is the answer. If you answer everything correctly, you will be able to get 6 marks. This is a question from October-November 2016. Question 2. This question is about atoms, ions, and isotopes. So after doing a few questions, I think you are already familiar with how to answer these types of questions. Question A is asking you to define the nucleon number. Just get the definition from the notes given over here. Nucleon number is the total number of protons and neutrons in a nucleus of an atom. Now question B is asking you to give the electronic structure of the following atom and ion. Now sodium has 11 protons. That means it has an electronic structure of 2 on the first shell, 8 electrons on the second shell, and 1 electron on the outermost shell. Now P means phosphorus. If you refer to the periodic table, you would see that phosphorus has 15 proton numbers. However, as you can see here, it has received 3 electrons in order to become an ion which is stable. Therefore, it has a total of 18 electrons. If we write the electronic structure, it would look like this. The first shell containing 2 electrons, second shell containing 8 electrons, and the final outer shell containing 8 electrons, a complete of 18 if totaled up. Question C, state one medical use of radioactive isotopes. Now if you look at your textbook, you will realize that there are a few examples of isotopes, and each of them have different uses. For example, to check for leaks, to treat cancer, to kill germs and bacteria. So in your answer for this question, you can pick any one of them. So I've just picked one and write to treat cancer. Question D, what is meant by the term relative atomic mass? If you refer to the notes, number 3 will tell you the definition of RAM, which is the average mass of atom of an element, the number of atoms of the element contained in 12 grams of carbon-12. This is the common example that is given when RAM question is being asked. Question E, suggests why the relative atomic mass of chlorine is not a whole number. Now the RAM for chlorine is 35.5. The reason is because chlorine has more than one isotope, and the masses of these isotopes' mass number are averaged. This is a question from May-June 2018, question 3. I hope this type of question is becoming easier for you to answer. Now let's look at the first particle, which is sodium, with 11 proton numbers. We have a similar electron number as this is an atom. It says it has 23 nucleon number. That means the neutron is nucleon minus your proton, giving us 12 over here. Now this one is an ion which has received 1 electron. Previously it had 17 proton. If it has received 1 electron, it would become 18 electrons. The number of nucleons is neutron plus proton, giving us 17 plus 20, which is 37. And the final one is 26 proton number. So let's look at our periodic table. 26 proton number means this is an iron, so we should just write iron over here. However, the electron number is not same with the proton number. It has reduced by 2 electrons. That means Fe has actually donated 2 electrons. So we are going to write 2 plus over here. This is another question from February-March 2019. So if the number of electrons has decreased by 1, that means the charge is plus 1. If the charge is 0, that means your proton and electron is equal and the electronic structure is similar with your electrons, which is 2.8. If the charge is negative 1, that means it has received 1 electron. Previously it was 9. Question BI. Carbon is an element. Define the term element. A substance made up of only one type of atom and cannot be broken down into anything simpler. Please memorize this definition. As you can see, it is a very famous question. Question 2. Carbon with 6 nucleon, 13 nucleon and 14 nucleon are isotopes. Complete the table. Now proton number is similar for all three. Neutron numbers are nucleon number minus proton. So 12 minus 6, you would get 6 neutrons here. 13 minus 6, you would get 7 neutrons here, and 14 minus 6, you would get 8 neutrons here. This is the specimen paper 2020. Question 2. The table gives the composition of 3 particles, so you have the number of protons, electrons, and neutrons for each particle. Question A. What is the evidence in the table for each of the following? They are asking you to give the evidence why particle A is considered to be an atom. Now, if your proton number and your electron number are equal to each other, it means that this is an atom. Question 2. A, B, and C are all particles of the same element. They are the same element because they have the similar number of protons. Question 3. Particles A and C are isotopes of the same element. Now, as mentioned, isotope means they have the similar number of proton but different neutron numbers. Question B. What is the electronic structure of particle A? Now, let's look at the table. Particle A has 15 electrons. This means that it has 2 electrons on the first shell, 8 electrons on the second shell, and 5 electrons on the outermost shell. Question 2. Is element A a metal or a non-metal? Give a reason for your answer. Now, element A is non-metal. The reason is because it has 5 valence electron. 5 valence electron means valence electron is the term that you use to define the number of electron at the outermost shell. And it says 5 here, therefore it needs another 3 electron in order to become stable. Therefore, this is non-metal. A metal element usually donates electron and not receive. Now, this is the specimen paper of 2023, question 2. Magnesium, calcium, and strontium are group 2 elements. Question A. Complete table 2.1 to show the electronic configuration of calcium atom. Now, if you look at the periodic table, you would see that calcium has 20 proton numbers. So if this is an atom, it means that 20 proton equals to 20 electrons. So 2 on the first shell, 8 on the second, 8 on the third, and 2 on the last, giving us a total of 20 if you add up. Question B. Describe how the electronic configuration of strontium atom is similar to the electronic configuration of calcium atom. Now, since they are both placed in the group 2, this means that they both have the valence electron, that is 2. You could say same number of outer electrons or valence electrons, you would still get a complete 1 mark. Question 2. How is strontium atom different from the electron configuration of calcium atom? Now, As you can see here, strontium atom is placed below calcium atom. This means that strontium has 5 shells and calcium has 4 shells only. Question C. Calcium reacts with cold water to form two products, a colorless gas P which pops with lighted spleen. So this question is not exactly related to this chapter, and you will come across this question with me in the next chapter discussions. This is a question from October-November 2019. Question 1. The periodic table is very useful to chemists. Refer only to element with atomic numbers of 1 to 36 in the periodic table provided when answering this question. Now, they're asking you to identify the element which has exactly 9 protons. 9 protons would be fluorine, an atom that has 0 neutrons. Now, as you can see here, hydrogen has 0 neutrons, has atoms with exactly 23 electrons. This means that it also has 23 protons. In your periodic table, vanadium gives you 23 protons. Question 4 has atoms with electronic structure of 286. If you total this up, you would get 16 electrons. An atom with 16 protons would be sulfur. Question 5 forms ions with a charge of 3 negative containing 18 electrons. Now, if the charge is negative, it means that it has received 3 electrons. If it has received 3 electrons to become 18, this means that previously it was, now it's 288, it means that previously it was 285. 285 gives us 15 electrons, or in another word, 15 protons. 15 protons means they are phosphorus. Next forms ion with a charge 2 plus containing 10 electrons. So now it has 28. If it is 2 plus, it means that it has already donated 2. So this gives you 12 electrons, which is similar with 12 proton. An atom with 12 proton is magnesium. The last one has a relative atomic mass that shows it has at least 2 isotopes. So this one is quite famous, and we know that it is chlorine. Chlorine is the one which has multiple isotopes, and that the relative atomic mass is actually an average of several isotopes. B. State which metal in the first 36 element is the group 1 element which reacts most vigorously with water. Now, since the question says that they want up to the first 36 element, rubidium will not be included because it has 37 protons. So we will just look at the first 3 elements, which is lithium, sodium and potassium. Now group 1 reactivity is such that as it goes down the group, it becomes more reactive. So potassium will be the most reactive in group 1 here. Number 2, reacts with air to form lime. Now lime is calcium oxide. This means that something adds with oxygen gives you calcium oxide. So obviously the answer here would be calcium. Next question C. One element in the first 36 which is used as fuel in the fuel cell. Now the most common element which we usually use in fuel is hydrogen. Question 2. Write the overall chemical equation for the reaction which occurs when the element in hydrogen, they're referring to, reacts in a fuel cell. So what happens is that hydrogen would usually react with oxygen to form water, but this question is 2 marks, so please do not forget to balance this equation. After balancing, your equation would look like this. Now this is a question from February-March 2017, question 3. It says that nitrosyl chloride is a gas at room temperature and it has the structure shown. Says here it has double bond between oxygen and nitrogen and a single bond between chlorine and nitrogen. Complete the dot and cross diagram to show the arrangement of the outer shell electrons in the nitrosyl chloride. Since they're asking for only the outer shell electrons, let's look at the valence electron for each of this element. As we can see here, oxygen has a valence electron of 6 and chlorine on the other hand has a valence electron of 7. So this is how your structure is going to look like. And now we will complete the drawing for nitrogen with 5 valence electrons. So we need to make sure that each of these elements would have 8 electrons, which is octet. So we need to draw the valence electron for nitrogen in a way that every element receives 8 electrons on the outer shell. So since oxygen has only 6 electrons here, I'm going to add 2 over here. to make it a complete of 8. And since chlorine only have 7 electrons here, I will add another one over here to make it complete 8 electrons. Now as you can see over here, nitrogen has 4 electrons here and 2 electrons here, which makes it only 6 electrons, and I am going to add another 2 electrons over here, which is the right amount as nitrogen has a total of only 5 electrons on the outer shell. So this is how your dot and cross diagram would look like. Question 2. Nitrosyl chloride has a boiling point of -6 degrees Celsius. Explain why nitrosyl chloride has a low boiling point. The answer is that there is a weak force attraction between this molecule structure. Therefore, only a little bit of heat is usually required in order to break the bond that is between them. This is a question from October-November 2017, question 2. Complete the table to show the electronic structure of the atoms and the ions. So we have 4 different elements here, 2 of which are atoms and 2 of which are ions. Now as for ions, the number of protons are not equal to the number of electrons. Before you answer this question, you can refer to your periodic table to obtain the number of protons at the left bottom of each element. Now these are the proton numbers of each element. Since fluorine is an atom, you would have a similar electron number, which is also 9, and this is how you'll get your electronic structure. Silicon is also an atom here, so it has a similar number of electrons. Your electronic structure would have 2 electrons on the first shell, 8 on the second shell, and 4 on the final shell. Now as for calcium, this is an ion. The atom has an electron configuration of 2882. However, since this is an ion which has already donated 2 electrons, the electron configuration would only be 2.88. And the last one is also the same. It is a nitrogen ion. A nitrogen atom has an electronic configuration of 2.5. However, if it has received 3 electrons in order to become stable, it means that outermost electron shell has 8 electrons now. And this is how the electronic structure for nitrogen ion would look like. Question B. Predict the formula of the compound formed between Ca2 plus and N3 minus. So what happens here is that the charge would cross multiply. So what happens here is the charge would go to the opposite side of the compound, giving you Ca3N2. So this is the formula of your compound. Question C. Draw a dot and cross diagram to show the electron arrangements in the 2 ions present in lithium chloride. Now before we draw our cross and dot diagram, please write down the electronic structure for each of the elements. So as you can see here, lithium is a metal since it will donate 1 electron, and chlorine is a non-metal and it will receive 1 electron from your lithium. Now this is what the lithium atom and chlorine atom would look like. However, each of them are not stable because lithium has only 1 electron on the outer shell, and it needs to get rid of it by donating them to chlorine, so that chlorine could receive 1 electron to become 8. So what happens is that the electron on the outer shell of lithium would go to chlorine, and since the question is only asking you to draw the outer shell electrons, it's not necessary to draw the first shell of chlorine. So this is how your dot and cross diagram would look like, but it's still incomplete because we have not written down the charges on the ions. Since lithium donated 1 electron, you will put a plus, and since chlorine received 1 electron, you will put a minus charge. This is how you get a complete 3 marks. Moving on, question D. Sulfur dichloride is a covalent compound. Now covalent compound is a compound which is between a non-metal element and a non-metal element. It has a structure chlorine with sulfur and another chlorine on the other side. Draw a dot and cross diagram to show the electron arrangement in a molecule of sulfur dichloride. Show outer shell electrons only. Again, before you draw, always write down your electron configuration first. Now as you can see here, chlorine has 7 electrons. It means that it requires 1 electron from sulfur, and sulfur has 6 electrons, so it requires 2 electrons in order to become stable. So this means that they will be sharing their electron with each other. So this one is slightly different with your ionic compound because instead of donating and receiving, they both require electrons to become stable, so they would be sharing electrons instead. So following the structure that has given in the question, you have sulfur in the middle with chlorine on each side. Now chlorine has a valence electron of 7 electrons, so it would look like this. And sulfur has 6 valence electron, which means that it has to share 1 electron over here with chlorine in order for chlorine to become stable of 8 electrons. Since I have already drawn 2, I need to draw another 4 electrons, and it's going to look like this. So if you look at your atom separately, you realize that chlorine has 8 electrons, sulfur alone has 8 electrons as well, and chlorine has 8 electrons. So this is how you get a complete 3 marks. Now question E is a continuation of the same question. In terms of attractive forces, explain why lithium chloride has higher melting point than sulfur chloride. Now lithium chloride is an ionic compound and sulfur chloride is a covalent compound. Ionic compound is between metal and non-metal, and covalent compound is between non-metal and non-metal. Now sulfur chloride has an intermolecular forces compared to lithium chloride, which has electrostatic forces. Intermolecular forces are typically weaker compared to electrostatic forces. Therefore, it requires more heat energy to make or break the bond of lithium chloride. Question F suggests the identity of covalent compound with a higher melting point than lithium chloride. So if you refer to the notes, you would see that for covalent bonds, you have simple covalent bonds which look like this, and also you have giant covalent structures which look like this. Even though they're covalent bond as well, they actually have a very high melting and boiling point, as they are made up of giant covalent structures. So there are a few examples for this, which are graphite, diamond, silica, and also silicon oxide. So you can use one of these as an example, and I'm going to use silicon oxide over here. This is a question from February-March 2018, question 1b. NF3 has covalent bond. What is a covalent bond? If you refer to your textbook, you would come across the definition of covalent bond, whereby it means atoms that share 2 electrons together. So you could simply say that covalent bond is a shared pair of electrons between 2 atoms. Question 2. Complete the dot and cross diagram to show the electron arrangement in a molecule of NF3. Show only the outer shell electrons. Again, let's write down the electronic configuration for both these elements. Nitrogen has a valence electron of 5 and fluorine has a valence electron which is 7. So I have drawn 7 electrons on each of fluorine shell, and as you can see, I have donated 1 electron from each fluorine atom to nitrogen. Since nitrogen has 5 electrons, I'm going to distribute it equally to fluorine, giving each one of them 1 electron. This way fluorine has complete 8 electrons on each of its outer shell, and as you can see here, if you count the number of electrons, nitrogen only have 3 electrons drawn, and I will draw another 2. Now nitrogen has a complete 8 electron as well on its outer shell. So when you draw the dot and cross diagram, please be reminded that you need to separate each element, one with cross and one with dot. Now this is a question from February-March 2019, question 3. Fluorine is a group 7 element. Fluorine founds compound with metals and non-metals. Predict the physical state of fluorine at room temperature and pressure. Now typically room temperature means it could be somewhere about 25 degrees Celsius, and room pressure is at 1 atm. Now fluorine is a gas at room temperature. As it goes down the group, it will turn into liquid and solid. B. Fluorine exists as a diatomic molecules. Diatomic molecules mean that you typically can find 2 at the end of the gas, something like this. And group 18 elements are usually called as monoatomic molecules. Complete the dot and cross diagram to show the electron arrangement in a molecule of fluorine. Now fluorine has an electronic structure of 2.7. This means that it has 7 electrons on the outermost shell. And I'm going to draw another 7 electrons for the other fluorine atom. And when they share 1 electron with each other, they would make a complete 8 electrons on each side. Moving on, question C, write a chemical equation for the reaction between sodium and fluorine. So I think this is pretty simple. All you have to do is when sodium reacts with fluorine, it would form sodium fluoride, and now you have to balance the equation by putting 2 here and then another 2 here. Then you would be able to get full 2 marks if you write like this. Question D, explain why chlorine does not react with aqueous sodium fluoride. Now this question is not exactly for this chapter. This is for chapter 9, and I would explain this type of question in another video. This is a question from May-June 2019, question 3. This question is about phosphorus and compounds of phosphorus. Compounds of phosphorus means an element which is chemically joined with phosphorus. Phosphorus has the formula of P4. Some properties of P4 are shown. So as you can see here, melting point and boiling point of phosphorus are pretty low. They are non-conductor of electricity and they are insoluble in water. Name the type of bonding that exists between the atoms of P4 molecule. Now since this is a molecule, the type of bond that exists would be covalent. There are only 2 types of bonds that exist. One is ionic and the other is covalent. So ionic is between metal and non-metal, and covalent are between non-metal and non-metal element, or just within the molecule of a non-metal element. Now question 2, explain in terms of attractive forces between particles why phosphorus have a lower melting point. Now this is the similar question that we did before. If it has low melting point, it's because it is covalent bonded, and covalent bonded has a weak force. If you have a weak force, it means that we don't need much heat or energy to break their bond. Question 3, explain why phosphorus is a non-conductor of electricity. Now in order to conduct electricity, there must always be free moving ions. Next, question B, phosphorus reacts with water. They want you to find the chemical reaction for this one and also the type. And this is about acidic oxide. So question B and C is not exactly related to this chapter, and we will discuss this in another video. Moving on to question D, which is a continuation. Says D-phosphine has the formula PH3. Complete the dot and cross diagram to show the electron arrangement in a molecule of phosphine. Okay, again, it's simple. What you have to do is find the electron arrangement for each of the element first. Now, phosphorus has the valence electron of 5 and hydrogen has the valence electron of 1. So this is the valence electron for hydrogen element on the outermost shell. And as phosphorus has 5 electrons, I will separate them equally, giving 1 electron to each hydrogen atom. So after drawing out 3 electrons, there are balance of another 2 electrons to be drawn, which can be placed over here. Now this will give you a complete 8 electrons for phosphorus and a complete 2 electrons for each hydrogen element. Question E says that phosphine has a similar chemical structure to ammonia. Ammonia acts as a base when it reacts with sulfuric acid, and they're asking you the term of base. So this question is also not related to this chapter. It's chapter acid, alkali and base, and I will discuss it in another video. Now this is a question from May-June 2020, question 2. It says that fluorine forms both ionic and covalent compound. Magnesium reacts with fluorine to form the ionic compound magnesium fluoride. Now as I mentioned before, ionic compound is between metal and non-metal. Over here, your magnesium is metal and your fluoride is non-metal. The electronic structure of an atom of magnesium and atom of fluorine are shown. So as you can see here, fluorine has an electron configuration of 2.7 and magnesium has an electron configuration of 282. Question 1. Complete the dot and cross diagram to show the electronic structure of one magnesium ion and one fluoride ion. So if you look at the electron configuration, you can see that the outermost shell does not have a complete 8 electrons. Therefore, magnesium needs to donate 2 electrons and fluorine needs to receive 1 electron in order for both of them to be octet. Octet means a complete 8 electron on their outer shell. So as for magnesium, after donating 2 electrons on their outermost shell, they would only be left with 2 shells, and this chart shows that they have donated 2 electrons. Now fluorine on the other hand requires 1 electron. So they will be receiving 1 electron from magnesium, forming the charge of -1. Now the question 2 is asking you what is the formula of magnesium fluoride? Since magnesium has the charge of Mg2+ and fluoride F -1, their numbers will cross each other, giving you Mg1 and F2. So the formula of magnesium chloride would be MgF2. Now magnesium fluoride does not conduct electricity when it is solid, and as mentioned before, in order for it to conduct electricity, it needs to have free moving ions. And when anything is in solid state, there will not be any free moving ions or electrons in that state. Now what can be done to solid magnesium fluoride to make sure that it conducts electricity? So in order for it to conduct electricity, you need to have free moving ion. What you could do is from solid, you can turn it into liquid. And how do you do that? Now what you can do is heat it up until it becomes molten. Molten is just a term to describe melted. So this is your answer. Moving on to question B, which is a continuation. Carbonyl fluoride is a covalent compound. The structure of a molecule COF2 is shown. Now complete the dot and cross diagram to show the electron arrangement in a molecule of carbonyl fluoride. Again, you need to write down your electron configuration of each element. Okay, so as you can see here, fluorine has an electron arrangement of 7 electrons on the outer shell, 4 for carbon and 6 for oxygen. Now I'm going to draw the one for fluorine first. So fluorine would have 7 electrons on its outer shell, sharing 1 electron with carbon. And now for oxygen, oxygen has 6 electrons and would share 2 electrons with carbon. Now carbon has 4 valence electron, which means that since this shows double bond, it means that there will be 4 electrons present in their bond. Putting another 2 electrons here, 1 electron for fluorine and another for fluorine. So carbon has 4 electrons, adding up with the 4 electrons that are shared from fluorine and oxygen. This would make carbon to have a complete 8 electrons. Fluorine also have a complete 8 electrons from carbon, and oxygen also have complete 8 electrons, receiving 2 electrons from carbon. You can achieve 3 marks from this. The next question. The melting point of magnesium fluoride and carbonyl fluoride are shown. As you can see here, magnesium fluoride has a very high melting point. However, carbonyl fluoride has a low melting point. Magnesium fluoride is an ionic bond and carbonyl fluoride has covalent bond. Now the question is asking you to explain, using your knowledge of structure and bonding, why magnesium fluoride has a high melting and boiling point. Now the forces of attraction between oppositely charged ions need a lot of energy to break. An ionic bond consists of electrostatic force between their ions. Question 2, explain why carbonyl fluoride has a low melting point. So the forces of attraction between molecules are weak for carbonyl fluoride, therefore they only need a small amount of energy or heat to break their bond. So as you can see here, this is quite a famous question that they would ask, why ionic bond and why covalent bond have either strong or weak melting point. So please remember the explanation for these types of questions as they carry quite a high mark. This is a question from February-March 2017, question 2. Carbon and silicon are elements in group 5 in the periodic table. Now both carbon and silicon exist as more than one isotope. Define the term isotopes. Now if you refer to the notes that I have uploaded, you will find a list of definition for this chapter, and over here you can have the definition of isotope. Isotopes are atoms of the same element with same proton number but different neutron numbers. B. Complete the following table which gives information about carbon atoms and silicon atoms. So in this table, you need to find the proton number, the electronic structure, nucleon number, and number of neutrons. In order to get your proton number, you can refer to your periodic table and get the number of proton at the bottom here. So as for carbon, there are 6 protons and silicon has 14 protons. Since both these elements are atoms, it means that their proton number are equal to the electron numbers. So the electronic structure for carbon would be such that the first shell contains 2 electrons and the second shell contains 4 electrons. As for silicon, you would have 2.8.4, giving you a total of 14 electrons as well. Now, in order to find the neutron number, your nucleon have to minus the proton. So for carbon, you would get 6. And for silicon, 28 minus 14, you would get 14. Now question C. Silicon has a giant structure which is similar to the structure of a diamond. Name the type of bond which is present between silicon atoms in silicon. So we only have two types of bond. One is covalent and one is ionic. Since this is a non-metal element, the type of bond present in your element would be covalent. Question 2. Suggest two physical properties of silicon. Now silicon is a non-metal. Use your knowledge of structure and bonding to explain why silicon have these physical properties. Even though silicon has covalent bond, which we discussed earlier, has a low melting point and boiling point, however, silicon is a little bit different with other non-metals as they have giant structure of covalent bond instead of simple covalent structure, which means that they have a high melting and boiling point because the bonds between the atoms are very strong. Therefore, it requires a large amount of energy to break them apart. Now, the second property of silicon, which is a non-metal, would be non-conductor of electricity. And if you have watched the previous video, you would realize that in order for electricity to be conducted, there should always be free moving ions. This means that if this is a non-conductor of electricity, the reason would be no moving ions present. Question D is asking you about sample of air and why carbon monoxide should not be inhaled. Now this question is not related to this chapter, so I will skip it and we can discuss in another video. Now this is the continuation of the same question. E. Carbon dioxide is a gas at room temperature and pressure, whereas silicon oxide is a solid. So they're asking you to name the type of structure which the following compounds have. As we have discussed before, silicon dioxide has a giant covalent structure. On your notes, you will be able to see a few examples of giant covalent structure and how they look like. Some of them are graphite, diamond, and silica. So as you can see here, the name of the type of bond or the name of the structure is macromolecular. So as the name for the type of structure, you could either say macromolecular or you could just say giant covalent bond. As for carbon dioxide, it is just the element of C and O2. So this one is between two non-metals as well. However, they are just a simple covalent structure. Now question 2. Use your knowledge of structure and bonding to explain why carbon dioxide is a gas at room temperature and pressure, whereas silicon oxide is a solid. Now again, this question is similar with the one that we have discussed before. A simple covalent structure has a weak force, whereas a macromolecular structure has a very strong force between them. So your answer could say that carbon dioxide has weak force of attraction, so it requires less energy to break the bond, whereas silicon oxide has a strong force of attraction, so they require more force to break them apart. That is why they are in a solid state. Question F. Silicon oxide is an acidic oxide when silicon oxide reacts with alkalis. Now this question again is not related to this chapter, so will be discussed in another video. This is a question from May-June 2018, question 4. It says that potassium reacts with bromine at room temperature to form potassium bromide. Write a chemical equation for this reaction. Now I'm only going to discuss the questions which are related to this chapter, and one of them is B. Says that potassium bromide exists as an ionic lattice. Now potassium bromide does not conduct electricity when solid, but does conduct electricity when it is molten. Molten is just another term for melted. Question I. What is meant by the term ionic lattice? The definition is that it is made up of positive and negative ions in a regular pattern. Now an ionic lattice compound looks like this, and this is typically between a metal and a non-metal element. So it is held by a force called electrostatic, and they are usually oppositely charged ions. Question 2. Explain why potassium bromide does not conduct electricity when solid but does conduct electricity when molten. So again, as we know, in order for electricity to be conducted, there must always be free moving ions. And ions are not able to move in a solid state. However, when they are melted into liquid, there can always be free moving electrons. So you could simply answer and say that in solid, ions do not move, but when molten, the ions are mobile. Mobile means they are free to move. Now question C is about electrolysis, and it will be discussed in another video as well. This is the question from February-March 2019, question 3E. Tetrafluoromethane and lead fluoride are fluorides of group 5 elements. Some properties of tetrafluoromethane and lead fluoride are shown in the table. So in this table, you could see their formula, melting, boiling point, and the conductivity of electricity when they are in solid and molten state. The first question is asking you to find the formula of lead-2 fluoride. Now lead has a charge of Pb2+, and fluoride is F-1. So in order for you to find the formula, always remember to cross their charges. So you will be getting 1 element for lead and 2 element for F, giving you lead F2. Question 2. What type of bonding is present between the atoms in tetrafluoromethane? Now tetrafluoromethane is a non-metal element. Since we only have 2 types of bond, which is ionic and covalent, the one between the non-metal would be covalent. Question 3. What type of structure does solid lead fluoride have? Solid lead fluoride is between a metal and a non-metal element. So the type of bond that they have is an ionic bond. However, the type of structure that they have is ionic lattice. Question 4. Explain in terms of attractive forces between particles why lead-2 fluoride has a much higher melting point than tetrafluoromethane. So I'm sure you already know the answer by now. When it is an ionic, it has strong forces, therefore much more energy to break them apart. So this is your answer. Please be familiar with this question as it carries a high percentage of mark. Now this is the question from May-June 2019, question 2. You have got 3 different types of sodium here with different nucleon numbers, and they are called isotopes. The first question is asking you describe how these sodium isotopes are same and how they are different in terms of the total number of protons, neutrons, and electrons. So as you can see on the diagram here, they have the similar number of protons. However, they have a different nucleon numbers, and nucleon numbers are the number of protons being added up to the number of neutrons. This means that they have the similar proton number, however a different nucleon and neutron numbers. Now, since they are all atoms, the number of protons are typically the same with the number of electrons. So your answer would be same protons and electrons, however different neutrons and nucleons. Question 2. Why do all 3 isotopes have an overall charge of 0? If they have an overall charge of 0, this means that these elements are atoms. And atoms consist of the similar number of protons and electrons. So you could say that the reason is because they have the same number of protons and electrons. Question 3. Why do all 3 isotopes have same chemical properties? They have the same chemical properties as they are made up of the same element from the same proton and electron number being in the same group in your periodic table. So your reason would be such that they have the same number of electrons and same number of valence electron on the outer shell. Now the last number of electrons on the outer shell is what determines the group number for each element. So since they are all having a valence electron of 1, they will all be in group 1. So this is why they have the similar chemical properties. Question 5. Why do sodium ions have a charge of positive 1? So as I have explained here, since they have an electron configuration of 2.8.1, the last number of electron does not meet an octet value, which is a complete of 8 electron. Therefore, in order for this atom to be stable, it has to donate 1 electron. So your answer would be that it donates 1 electron. After donating 1 electron, the electron number would become 10. However, the proton would still remain, and protons are positively charged. This means that it has 11 positive charge and 10 negative charge, making this positive 1. Now question B is not regarding this chapter and will be discussed in another video.